same for the office hours. So thank you all of you for staying over for the office hours. We wanted the office hours to be a free flow discussion. And I would encourage, if the people who are attending the office hours have any questions they want to ask us live, then, we'll start with those and we are happy to answer them. And then we had also collected some general questions as part of the registration form. So we have some slides over those also. So maybe.
Yeah. And I'm not sure if you saw, but Dino said that he'll come to the office hours, but he'll be late. So okay. Regarding the statistics discussion module, just so you know.
Yeah. And we have Patrick Clemens that raised his hand.
Yeah. So Patrick, you want to go first?
Sure. So I was supposed to ask you about Pegasus clustering from Tuesday, from what day was that? Tuesday.
Yeah. So I think actually, so what Pegasus clustering allows you to do is, cluster jobs, short-running jobs, which you define in your abstract workflow into larger chunks. So that, let's say, like, you had 10 parallel jobs, you'll end up, you can cluster them into one Condor job. So that's a feature which Pegasus provides out of the box. And just trying to get so if you go to the Pegasus website in our documentation guide, so if you want to go to chapter 12, then we have a section on job clustering, and some sort of clustering techniques that we support are usually like what a lot of our users end up doing is they cluster short running jobs on the same level into some chunks, and then those chunks you can specify to Pegasus as Pegasus profiles in terms of hints as to how you want the jobs to be clustered. Or if you're associating runtimes with your jobs, then you can do a runtime based clustering where you can tell Pegasus that each Condor job that gets run should be running for, let's say, 10 minutes, and then Pegasus will try to do the billing for you per level. And then alternatively, you can also do a label-based clustering where, like, as a workflow developer, you yourself have an idea that, how you want the jobs to be clustered in certain scenarios. So you can associate labels with your jobs in the abstract workflow, and then, get Pegasus to cluster those jobs together. And then when Pegasus runs these clustered jobs, there are two options. One is, you can run them one after the other on a single node, or you can also use a tool which Scott Callahan referred to in his tech talk, which they use, and that's called Pegasus MPI cluster. So that allows you to give a subgraph of tasks, and it will run that tasks in order as an MPI job using master worker paradigm.
That's great. Can I ask two questions? So this clustering happens at the time of DAC creation, right? It's not dynamic as the workflow executes.
Yes, it happens at the planning time before we hand off, before we end up generating the Condor submit files.
And then could you scroll to a spot where you tell Pegasus like how to make the clusters? Like if I have jobs I want to label, do you do that like job equals and then give it like some?
Yeah, so basically with each job, you can just associate a Pegasus profile called label and say that the label value for the job is this.
And I should say, Patrick, but depending on the workflow structure, sometimes there's a very natural way of doing that labeling, right? You already have, like a site or like something like that, where it's like logically, oh, I'm going to run this as one unit, right? And then it makes sense to do labels. A lot of our users, like if all you want to care about is the short tasks, level based is easier. Like this, go show it level one.
Yeah. It's not
Okay, right. So like it's just like all the jobs on one level that same type basically get put together. The other reason for doing this is that if you have jobs that depend on the same input data, you only have to do a transfer, or Pegasus only has to do a transfer for that cluster, right? So you can actually save on data transfers by doing it once and then reusing that data for all, like for the tasks in that cluster, and you can mix and match. It doesn't have to be all or nothing, right? So that's Pegasus will figure that out for you, that if you have a one input that is reused and individual inputs for the rest of the jobs, that's still fine. Pegasus will deal with that.
Thanks, guys. It's really interesting. It doesn't quite work, I think, for what we're doing, but that's really interesting. It's a nice feature.
Yeah, and I think like also this goes hand in, like the case which you are alluding to is also probably addressed by Condor Glidance, right? If you were to think about it.
Right. If I use this in combination with Glidance, I could go get all the group together in one big job and then call Glidance once instead of for each individual job. I see what you're saying.
Yes. Or, you just grab the node once and then let Condor do its normal scheduling of the jobs, and then the jobs will end up running on the resources that you have procured. And because I'm doing screen sharing, I'm unable to see any shared hands. So somebody else will have to write the questions part.
For now, there is none for now.
Well, I have one more question if no one else does.
Yes.
So
Go ahead.
one thing that happens often enough that makes me want to ask about this. So sometimes when a workflow fails, Pegasus thinks that the job might have completed, but it either gave like bad output or it didn't complete quite right. And so in the database, it's marked, the job gets marked as like complete. So if I just try to do a Pegasus run, to restart it, it will get really confused because it thinks the job is done, but the output data isn't there. Is there a flag on Pegasus run that I can rescan the output directory and have it kind of use the output files as the indicator where their job's finished versus the database? Because right now I just have to create a new DAC, with an input thing around Pegasus plan. And then I have like a whole nother workflow, which is like not optimal, and they have to combine them later. If I could just have a flag on Pegasus run that rescans the output directory instead of using the database, that would be great. Is that possible?
So I think like I wanted to answer your first question first, because I'm surprised you're hitting into that condition. So essentially under the covers, what happens is, we hand over the workflow to Condor Dangman for execution. And then Dangman is responsible for executing or releasing the jobs in order, marking the jobs for failure in the DAG. And so when each job fails, there is a postscript associated with the job that looks at the kickstart output and tells Dangman for sure that this job has failed. And when Dangman sees that, it will mark the job as failure. And then eventually, let's say the workflow fails, then Dangman ends up creating a rescue DAG, and you submit the rescue DAG, it would start from the last failed job. So if you can share with us some submit directory of the situation which you are running into, that's something which Max and I would like to investigate further, because not many users report that particular scenario to us, and we don't encounter it usually.
Oh, okay. So I'm a unique situation. Yeah. Next time that happens, I'll definitely.
Yeah. But and then going back to your question about pointing to an output directory, so that's where like data reuse comes into the picture. So if I scroll up on my in the user guide, and I'll go here in mapping refinement steps. So Pegasus, since very early on has this notion of data reuse, where the underlying premise is that if Pegasus can discover some outputs in users' replica catalog, then it can do make style reduction of the workflow and say that if a file already exists in the catalog, then I can not run particular jobs. So you can give Pegasus the same DAX or the abstract workflow, but then point it to a previous output replica catalog where your outputs are registered, or any if your outputs, you're getting your outputs back to your local submit host, you can give the output dir as an input dir to the next run. And
Yeah,
then,
this is basically exactly what I do now, but it's at the planning, at Pegasus plan stage.
yes,
And I use a dash input option instead of the dash reuse
Yeah.
option. So I can look at that to be a little different, but I was just hoping that this was an option at the Pegasus run stage instead.
yeah, because at the Pegasus run stage, we are just literally submitting the Condor Diamond workflow as it exists right now. And so, initially when you first run the workflow, you invoke Pegasus plan, it creates the Condor Diamond workflow. And then you do Pegasus run. So if you keep on running Pegasus run again, then it will just keep on submitting the rescue diag, which, works for most of our users. And that's why, I was surprised at the case you're running into.
Well, thanks. I'm out of questions now, so I'll let someone else ask some.
Yeah. Should we check if Daniel is raising a hand?
Yes, hello, hi. Thanks to the Pegasus team. And then I'd like to ask a question to Karen or to anyone best suited to answer about using Docker containers within workflows and the concerns around what is staged and not staged and how volume mounts are handled on the Docker container. So I've looked into it a bit, and I was inspired by Karen, what you shared on Tuesday around showing a simplest case in 5.0 to use the API and how Pegasus uses sort of expected base configuration to get things to work more easily in version 5.0. And I've been asking or been thinking what additions would be necessary to just that base workflow definition to have it run, let's say, a Python container or a Docker container that has, let's say, a different version of Python installed in that. And I've got that Docker container or that Docker image as a tar. Can you talk about what the minimum things that would be needed to run that way? And
So,
thanks for taking
Max, you want to answer it or you want me?
Yeah, go ahead.
Okay, yeah. So I think so in general, Daniel, most of our users have started using containers, and we are supporting the containers pretty heavily. So essentially what it boils down to at the Pegasus configuration case is you specify to Pegasus that when you're, that this is a particular container that you want associated with a particular executable. So in your transformation catalog, for example, let's say you have a transformation called pre-process, you can now also specify a container that you want Pegasus to use to run this executable. And then you have sort of two options. So the containers will be shipped, can be shipped by Pegasus along with your input data to your compute site. So from that perspective, Pegasus treats Docker containers or Singularity containers similar to input data. So let's say you have a container hosted in Docker Hub, and you're running it on your cluster. Pegasus will have a data staging job that will pull down this container once, export it as a tar file, and then ship it along with the workflow to where the jobs land. And then, when Pegasus Lite starts up, we do the setup and the container gets invoked. And then, when you describe a container, you can also specify the volume once you want when Pegasus is starting that container.
Okay, yeah, thank you. And with that, so where it says bypass staging is true. If I've got a local image definition of a Docker image, what does bypass staging equals true mean in that case? Does it not copy the?
Yeah, it means that it will not go through the staging job, but the Pegasus Lite script will try to directly pull that container down from, let's say, a Docker hub.
Yeah, I actually, we shouldn't even suggest that, Karen. So the difference here, Daniel, like let's say that you have 1,000 jobs, right? If you have bypass staging off or false, one container, like that container is pulled once from Docker Hub or wherever it's hosted, and then shipped around to those 1,000 jobs. If you enable bypass staging here, each and individual of those jobs will do the pulling. So it's obviously, I mean, this is a scalability issue. For small workflows, it doesn't matter. But if you have a lot of jobs, yeah, that one does matter. And again, and then there's a lot of kind of details here about, yeah, it gets cached in nodes and things like that. But the preferred way would be to have bypass staging off. And I also think, like in your case, the wrapper shouldn't be too bad. I mean, it should really be just defining the container to use, and then the thing to know is also that you will be dropped into the user as the invoking user, right? So on the cluster, like whatever your username and UID is on the cluster, you'll be in the container. And the reason we do that is so you can access file systems and things like that with the proper UID. And I think that's, like, again, in your case, I suspect that could be very useful.
Yes, absolutely. I think that's, we want to use that feature because we don't want to expose root privileges for all of the users on the cluster. So,
but you can also do it for direct access to data, for example, and things like that. So shared file systems.
Okay, well, I think with the bypass, I think I'm just struggling with an issue where I'm not pulling the Docker images. I have them locally, and so I have to make sure I'm doing the right thing, because I do only want to provision those to, let's say, the work directory once, but I already have those, so I don't need to use the Docker protocol to go get them.
Yeah, so but you just specify the tarball instead, and you say, here's a Docker image. I have it already pulled. But I would still use turn off bypass staging. And Karen, I think we should remove that to not cause confusion in the documentation.
Yes, I think we just maybe ended up doing it just to highlight like the Python API parameters, but we'll do that. And in general also, like, for example, Docker has started now charging for the number of pulls you do in a certain period of time. So, in general, like, it's not going to be a good option.
Okay, well, I'm going to make use of this, and I'll follow up. But thanks for dedicating some time to this.
Okay, maybe we can move to the next question. Does anybody else have questions that they want to ask live?
So Karen, Dino is back if you wanted to discuss that.
Okay. Yeah, hi Dino. So I did also reply back to you in Slack, and maybe, yeah, you did. Okay.
Right,
so
I can.
Maybe you should ask the question again so that everybody else knows it. Like, otherwise, it's just not everybody might be following the thread.
Oh yeah. So my question was about Pegasus statistics. As a CLI, it works great. Pegasus 5.0 added. Well, I believe it was earlier too, but it wasn't as advertised, or I didn't notice it. Up to Pegasus 5, they added Python classes, Python bindings for their Stampede statistics database, and my knee-jerk reaction was seeing that it used SQL Alchemy, that it'll be very much SQL Alchemy usage-like. So your tables will be objects, your queries will be methods that will compile into SQL queries, and you'll get back columnar or row verse data, which will be another object, etc. But that didn't quite work out like that for me. I wished to use the Stampede statistics database to essentially bundle a bunch of the statistics of 50 plus 60 workflows I ran as part of the testing with a publication, right? So that the plots and the data is repeatable, accessible, etc. right? But then I ran into a bit of a problem because I delved, I guess, too deep into the code and missed bits of documentation where the Stampede Stampede statistics database class doesn't quite work the way I imagined it to, I guess. And then I couldn't quite, use it. You don't get back objects exactly. It was just tricky. It worked in a mysterious way, not in a way that I wasn't accustomed to. That was the comment on my usage. So I'm wondering if there's a question like whether there'll be a more classical SQL Alchemy API to the Stampede statistic database. And a second question was, once I cluster my jobs in my Pegasus statistics output, I have the merged jobs, their IDs, their names, where they executed their timings, their memory footprints, etc. But I had a very hard time trying to untangle which job IDs from the graph ended up in a particular cluster job. And the reasoning there was that, these cluster jobs usually on average take some amount of time, but naturally because the underlying data is not uniform, they have some variance to it. And when you have a job that takes too long or a job that takes too little, it's telling you something about the underlying data, or it's telling you something about the instance, something went wrong, something went different than usual. And it would be interesting for me to get those job IDs out so that I can look at the data and see, okay, so this is obviously data related, or no, this instance suffered a failure that I couldn't notice, or something's going wrong. So my question there would be, how would I untangle the clustered data, clustered job ID? How would I use that to untangle what job IDs were clustered together in that particular job?
Yes.
So those are the questions.
Yes. So for that particular thing, we are recording that information in the database, but we haven't exposed it because, in general, Pegasus stats mainly focused on sort of aggregate statistics. So nobody ever asked us for that part. So that's something which, we can investigate and, implement. In terms of the SQL Alchemy aspect, we took this decision a couple of years back when we were building the dashboard that, for monitoring in general, we will provide a REST API for the users to use. And the underlying database schema for our workflow database is actually pretty complicated. So, we never even thought about, a person would want access to the SQL Alchemy objects directly. Even as developers, if we have to introduce a query, we ourselves, it takes us some time to figure things out because of the relations. It's like a highly normalized schema. So in general, we don't plan to expose a SQL Alchemy type API other than, if you want to just interface directly, like load the database as a SQL Alchemy construct and then do the mangling yourself. But I would, I would like to see if we can help you get the information you want and we'll work on extending both Pegasus statistics and our REST API to address these questions.
Thank you.
Yeah, because I know we have that information because in Pegasus Analyzer we are able to track what jobs failed so forth. Are there any other live questions? Okay, so maybe we got some questions from the users, when they registered for the workshop. So we have them collected here. So I think like one thing which came up a lot of times, on executing workflows is like, people asked about executing on Slurm clusters and in general, if you have parallel processing jobs. So for, the reality is like for MPI style jobs, obviously Condor is not a good fit. It's mainly geared for high throughput. So if you have like MPI jobs in your workflow, or you want to run them locally directly on your local cluster, then the way to go about it is to probably not fully ideal, but is to get Condor installed on a login node in a submit configuration where Condor is not responsible for managing your cluster. It just is a way of submitting to the underlying local scheduler, which can be PBS, LSF, SG, anything. And we have tried to sort of work on some instructions which makes it easier for users to do this. I think one of the other questions that come up in this case is, about Condor installation, whether the Condor installation needs to happen as root or as in user space. And there, we recommend that, we work with the sysadmins to make a case of Condor being installed once. Obviously, like, there's an option that you can run Condor in your user mode, but then if, a lot of users end up doing this on a login node, the sysadmins are going to see a lot of Condor daemons running, which is also not ideal. So our recommendation in general is to, work with the sysadmin to get Condor installed once so that, it works for all users. I don't know if anybody else on our development team wants to add anything on this. And the other thing I'd like to add is like, for environments like OLCF, where, they are making a Kubernetes cluster available, we have sort of gone with a containerized approach where you can have your workflow submit node fully as a container and you use that to run jobs. All right. So I'll just take a break and let Ryan answer this question. It's about the new Python 3 API and the use cases. So Ryan, you want to take this question?
Yeah, sure. So with the new Python 3 API and the 5.0 release, one of the things that we really wanted to focus on was, this is a good opportunity for us to make sure things are very usable and that the API is expressive enough so that, you can easily generate any kind of workflow that, fits your needs. And so that's why, as Karen mentioned in his previous presentation on day one of PUG, that you can generate catalogs, replica catalog, transformation catalog, site catalog. Additionally, you can create a properties file with the API, and then you can generate your workflow. And then one of the big things that we added is sort of wrappers around all of the Pegasus tools that you use the most. So like Pegasus Plan, Pegasus Run, Pegasus Status, Pegasus Analyzer, Pegasus Statistics, and even like Pegasus GraphViz. So in terms of its use cases, it's sort of similar as DAX3. You generate your workflow, but there's just more features added. And so we hope that when you write your workflows, it's a lot easier and you can express them in sort of less lines of code than you would have with the previous version.
Okay, and we had another question about data-driven workflows, which Ryan, I would request you to answer.
Yeah. So the question, was like, what about data-driven workflows that listen to available new data sets? And the solution that we have to this right now is with the Ensemble Manager. As I discussed in my presentation, we have this notion of triggers. Two of them. There's a time-based trigger where you periodically automatically submit new workflows to the Ensemble Manager, and then the Ensemble Manager will handle them. But then we have this file pattern-based trigger where it runs on a timer and you give it some file patterns and it looks for those files at every interval on the same node where the Ensemble Manager is running. And when it creates sort of the workflow and passes it to Pegasus, it passes as input all the paths to all those files. So in your workflow generation script, you can handle them however you see fit. So, this is really good when you just have some directory in your submit node that's sort of periodically getting new data and you want to process that new data on some time interval. Right now, this only works where the data resides on that submit node. But, in many of your cases, like the data might be it could be in the form of like a remote database or on a file server somewhere else, or, even in cloud storage. So if, there's anyone here in the audience that wants to share, like where do you get your data from that you would like to kick off your workflow? It'd be really useful for us to know, so we can sort of think about how we develop these triggers moving forward.
Ryan. So I don't know, like people attending, if you have any questions on the topics we are discussing, I would encourage you to ask questions on those.
Yeah, and then one more thing that I can also add, going back to the Python API, is that now, because you're able to sort of plan, run, and monitor your workflows directly from the API, if you have a very custom use case that's not supported by these triggers with the Ensemble Manager, you can easily build something on top of the API. Maybe you're polling a database or checking for files in a file server just with Python, all in that same script. Then you can generate your workflow and kick it off.
Okay. So the next question which we had was about the way we understood it is like, I guess people were asking about whether there were any such workflows in these domains. So I'll request George to answer this.
Yeah, so from what I know, we have Pegasus workflows in these areas. I haven't worked with computational chemistry or structural chemistry, but I've worked on a molecular dynamics workflow that was provided from collaborators at the spallation source in Oak Ridge National Laboratory. So that workflow is basically using NumD to do some calculations in the beginning, and then another piece of software that they've developed called Sasina to do trajectory calculation. and it's available on GitHub if somebody wants to check it out and see how NumD works. And we've also experimented and we have explored solutions with Dakota to do parameter sweeping and McFine. Regarding the Pegasus Hub examples, we don't have anything yet there, I think. Karan, do we have something there that I'm not aware of?
No, not right now, but you know, our hope is that as you know, we work on Pegasus Hub over the coming months, we'll end up adding more examples, and we also encourage our user community to contribute some examples that can be incorporated. All right. So then there was a general question about big data, data management.
For parameter sweeping or McFine, I'm happy to share what we have developed for that.
Okay, sounds good. So in general, like, you know, one of the selling points of Pegasus is the data management it tries to do for your user workflow. So this is just a simple answer in terms of, like, you know, at a high level, you know, Pegasus will discover locations of input data for you and then stage in input data, application containers or executables efficiently to your execution environment. So as an end user, you don't need to worry about, you know, where you're going to stage the data from, what protocol to use. Our data management layer supports a lot of underlying protocols. And then we also support staging out of outputs that are generated as your workflow runs to a location specified by the end user. Pegasus also has another powerful feature about data cleanup. So let's say you have very large workflows and they generate huge amounts of data, which is pretty common, for example, in bioinformatics fields also, where, you know, there are a lot of FASTQ files that your workflows might be referring to. Then this feature is useful where, you know, since Pegasus at the planning time is able to look at the whole DAG, it can identify at what points in the underlying graph it's safe to delete data sets. So Pegasus will automatically annotate your executable workflow with data cleanup jobs. And, you know, we have a pointer here into our documentation that goes in detail about the data management that Pegasus does for the workflows. So we have topics on replica selection, supported transfer protocols. As you can see, there are about 14 supported transfer protocols, credentials management on getting these transfers to work, how data can be staged to execution sites, how can the data be placed on output sites, data cleanup, and then also, you know, support for some metadata attributes that can be registered in our catalogs. And then Matt's mentioned in his OSG talk, the integrity checking that Pegasus now does for the workflows of the protocols. All right. So the next question which we had was approaches and tricks that can be applied to various problems to receive high throughput. So I'll request Matt to answer this.
Yeah, so actually, if whoever provided this question, if they are they here? Anybody remember? Right, so I think the confusion here, are we talking about high throughput or like quick turnaround time? Because I think it almost sounds a little bit like the question that, was it Eric that had it?
Yes.
And he had a really short job that he wanted to see coming back quicker. See, the reason I'm saying this is that the throughput is, in general, you don't have to do anything. That's just part of being running Pegasus, running Condor jobs. It's like you get it for free. Now there is a link in the user guide, the optimization link, that talks a little bit about what can you do to minimize this. And so we talked about job clustering already. This is one way where if you have really short jobs, there's a little bit of scheduling overhead on each job. So if you can cluster them together, you minimize that overall and you get better throughput. So that's the biggest thing, I think. There are a few other ones in here. I mean, obviously data staging. If you have, which is pretty uncommon, but if you have short jobs and large inputs, that's something that maybe you should look at, and then maybe improve the data staging again, because that would improve it overall. But without knowing more about the question, I think that's the more general answer I want to provide.
Okay. Thank you, Vance. I think this we have already answered about how containers are supported in Pegasus, and I'll just answer back to Daniel that if you get stuck anywhere, Daniel, Mats and I are happy to help you get your workflows configured to using containers.
Great, thank you. Appreciate that.
And then, we had a last question about Insitu analytics in a Pegasus-based workflow. So I'm hoping if the person who raised this question, if he's there, he or she is there, then, maybe they can ask in person. Otherwise, we just try to do our best answer gets, and I'll request Loic to answer this.
Yes, so at the time being, Pegasus has no real support of that kind of in-situ analytics workflow. We have a preliminary support for decaf, which is a in-situ HPC framework, which relies on MPI. So we did some work around that, even though right now the API is not ready to use to express decaf workflows. And we are doing some research effort regarding Pegasus and decaf for data space, which is another in-situ layer integration, and how we can leverage in-memory framework that are used for in-situ analytics into Pegasus workflows. So it's pretty early stage, but we are doing some work around that.
Thank you, Loic. And that actually brings us to the end of the questions which we had listed, or we had gathered that the users had for us.